We hear the term fossil fuel all the time, right? But what if that whole story isn't quite right? Today, we're drilling down into a pretty wild scientific debate about one of the most valuable resources on Earth, where oil really comes from.
You probably remember this from science class. Oil is a fossil fuel, right? It's the leftovers of ancient life, cooked for millions of years. But what if there's another story, a much more controversial one about its origins?
So where did this whole debate even come from? Well, believe it or not, part of it starts way out there, in space. When we find the building blocks of oil on lifeless moons, it makes you ask a pretty fascinating question. Could some of Earth's oil have a non-biological origin too?
Okay, first things first. Let's break down the theory we're all familiar with. This is the biogenic origin of oil, the story of how ancient life becomes modern fuel.
So, the very first ingredient in this ancient recipe is something geologists call a source rock. And you can really just think of it like a geological pantry, you know? It's packed with all the raw organic stuff you need to get the process started.
Now, this is a journey that takes an almost unimaginable amount of time, millions of years. It all starts when teeny tiny dead plankton get buried deep under the seafloor. Over time, the pressure turns all that organic goo into this thick, waxy stuff called kerogen. And then, the real magic happens. Intense heat from the Earth's core essentially cracks that kerogen, breaking it down into the liquid oil and natural gas we use today.
Now, the environment here is absolutely crucial. See, for this whole thing to work, all that organic matter has to land on an oxygen-poor seabed. Otherwise, it would just decompose. As millions of years of sediment pile on top, the heat and pressure just ramp up, turning that ancient seabed into what is essentially a massive hydrocarbon kitchen.
But, just making the oil isn't enough. Not by a long shot. For it to be a resource we can actually tap into, it has to collect and get concentrated. It needs to find its way into a porous rock, kind of like a sponge, and then get trapped there by a solid layer of rock on top. It's like winning a geological lottery. Literally everything has to line up just perfectly.
Okay, but now for the plot twist. There's this other theory, a much more radical one, that suggests oil's origins aren't in ancient oceans at all. It suggests oil forms inorganically, deep within the Earth's mantle. And get this isn't some new fringe idea. Nope, it's got a surprisingly long and distinguished history. We're talking champions like the famous naturalist Humboldt and even Mendeleev, the guy who created the periodic table. It was a huge focus in the Soviet Union for a while and was later brought to the West by the astronomer Thomas Gold.
And this quote from Humboldt himself, man, it just nails the core idea of the abiotic theory. He was in Venezuela and saw oil just seeping out of these deep, primitive rocks, and he figured, there's no way this came from fossils. It has to be coming from way deeper, driven by the Earth's internal heat.
So here's the absolute game changer with this theory. Instead of dead plankton, the raw material is primordial carbon, stuff that's been locked away in the Earth's mantle since the planet first formed, billions of years ago. This idea completely cuts life out of the equation.
And you might be asking, okay, but how would that even work? Well, there's actually a pretty plausible chemical pathway for this. It's called the serpentinite process. It basically says that under the insane heat and pressure of the upper mantle, water and carbon can react with certain minerals to cook up hydrocarbons. And here's the kicker. Scientists have actually done this in labs, proving it's chemically possible.
So we've got two totally different recipes for making oil. Let's put them side by side and see just how different they really are.
I mean, look at this. These two theories are just worlds apart on every single level. One uses dead life near the surface, cooked slowly over millions of years. The other uses ancient carbon from deep inside the planet, synthesized under extreme pressure. We're talking about a different source, a different location, and a completely different process.
So the big question is, how do scientists figure out which one is right? Well, it all comes down to the clues hidden inside the oil itself. Let's put the evidence on trial.
And this is where it gets super interesting, because for every piece of evidence, each side has a comeback. Take biomarkers, for example. These are specific molecules in oil that look like they could only have come from living things. The biogenic theory folks say, see? Proof. But the abiogenic theory camp fires back, nope, those are just contaminants from bacteria that ate the deep oil on its way up to the surface. It's a real scientific back and forth.
Okay, so point for the abiotic team. A huge piece of evidence came from this amazing place called the Lost City Hydrothermal Vent Field. Out there, scientists watched hydrocarbons forming in real time with zero biological input. This was a massive discovery. It proved that nature can, in fact, use these deep earth recipes to make the building blocks of oil.
But, and this is a big but, a major field test in Sweden that was supposed to be the final proof, well, it was kind of a bust. They drilled deep into this massive crater, a perfect spot to find oil seeping up from the mantle, and while they found some hydrocarbons, it turned out they came from their own drilling fluid. A critical test had failed.
So after looking at the history, the chemistry, and the real-world evidence, what's the final verdict? Where does the scientific community actually stand on this today?
Well, when you really weigh all the evidence, the consensus is pretty much crystal clear. While scientists totally agree that small amounts of abiotic hydrocarbons can form naturally, the evidence overwhelmingly points to a biological origin for the vast, massive petroleum deposits we actually use for energy.
And honestly, here's the bottom line. The real reason the fossil fuel theory wins out, it just works. It's not just some abstract explanation, it's a predictive model that has successfully guided geologists to discover pretty much every single oil and gas field on the planet.
Seriously, think about it. Every major oil field ever found was discovered by people looking for ancient seabeds and the exact rock formations predicted by the biogenic theory. It's a model that has quite literally fueled our modern world.
And it all circles back to rocks just like this one. This is an organic-rich black shale. It looks like a plain old rock, but it's so much more. It's packed with carbon from ancient life, it's a time capsule and a factory, the starting point for the oil that millions of years later ends up in our gas tanks.
So, while the mystery of our planet's vast oil reserves seems pretty much solved, that Challenger theory does leave us with a fascinating final thought. We've proven that oil is, for all intents and purposes, a fossil fuel. But we've also proven that Earth can create hydrocarbons from scratch, deep in its mantle. It just makes you wonder, what else might be cooking deep beneath our feet?